Okay, well, I guess we better do something. So here's our schedule. Today is the 24th. Month went by fast. So we're supposed to be on starting chapter 6. No.
6?
No, 5. Yeah. One of the most boring chapters in the book, chapter 5, the integumentary system. So, well, at least from now on, we're covering actual organ systems. So this is the first one. So we're going to do integumentary system, skeletal system, muscular system, and nervous system this semester. And then the rest of them will be in anatomy too. And what did we do last time? We didn't do any lab, did we?
Yeah, we did the microscope.
Oh, okay. So histology lab. Did I give a handout, a worksheet for
It was like a tissue worksheet.
tissues worksheet? Okay. Anybody bring that with them?
Mm-hmm.
Yeah. We can look at that. If you, I probably have more copies if you didn't bring yours. But I know we can look at that, and we can set up a few microscopes over here and look at. There's some tissues that you should be able to, that you should be familiar with seeing them under a microscope. So we can do that. I don't know. It's hard to have do much for a histology lab, a tissues lab, but we might if we have extra time, maybe we could start learning some bones today. I don't know. Or we could play with the anatomage table. See if we can find some integumentary stuff on there. But anyway, so we need to look at chapter 5, I guess. Nothing much exciting about this chapter, skin. Oh, they're working now? After you went to the next building? So apparently the restrooms are working. Okay. I don't know, let's look at this video. It's only a minute, if it works. If this link works. It's a commercial. Hmm. Well, that didn't work. Oh. A little bit.
Just a little bit.
This is just an ad for something.
Is there a particular video you're looking for?
Well, I don't know what this, I forget what this video, intro video was, but it's not, okay.
System, also known as the dermal system, is the largest system in the human body. It consists of structures that form the body's outer covering, and its functions include protection against the external environment, regulation of body temperature, regulation of hydration levels, sensory perception of touch, temperature, and pain, and synthesis of vitamin D. The major components of the integumentary system are the skin and the subcutaneous tissue. The skin consists of two layers. The epidermis, which is a superficial cellular layer of the skin, and the dermis, which is a deep connective tissue layer of the skin. The subcutaneous tissue, also known as the superficial fascia or hypodermis, is a connective tissue layer located immediately deep to the dermis. It's a seat of adipose tissue or fat.
Stop. If you are buying options, you're wasting your time and money. Hi.
I'm not buying options, I don't even know what that means. Um, Okay, back to. Okay, so here's a diagram of skin. Like we just saw in that video, the skin can be divided into two parts: the epidermis on top here, and then the dermis below it. The dermis is much thicker. The epidermis is just skin cells, just layers of cells, but down here in the dermis is where all the other stuff is. This would be a sweat gland and blood vessels and nerves and hair follicles with the hair shaft that comes out through the epidermis to the outside. This would be the sebaceous or oil gland that's connected to the hair follicle, and then every hair follicle has a little tiny muscle attached to it that we'll talk about later. And there's touch receptors, like the corpuscle. And then there's some adipose tissue in the dermis, but most of the adipose tissue is in the layer below that, the hypodermis, or subcutaneous. And most books do not consider the subcutaneous layer to be part of the skin. It's a separate layer below the skin. Okay, the word integument or cutaneous, those both mean skin. What else? We'll look more in some detail about the epidermis, but it's stratified squamous epithelium, so many layers of thin flat cells. And those skin cells have keratin in them. That's the same kind of protein that makes up hair and fingernails, but it makes skin cells tough and waterproof. Skin is the largest organ. That means if we would take your skin off and weigh it, it would weigh more than any other organ. What's the largest internal organ?
It's probably your intestines.
No, the small intestine would be the longest, I guess, organ, but what's the largest by mass? No, it's below the lungs. Above the stomach, below the lungs.
The liver?
Liver. Yeah, liver. It's pretty big. It's about the size of a football. It's not shaped like a football, but it's about the size of a football. Okay, functions of this integumentary system. Protection, sensation, thermoregulation, vitamin D synthesis. So what's that mean? Let's look at each of those a little bit. So protection, of course, because the skin covers your body. It's the first line of defense for keeping stuff out of the body. It says physical, chemical, biological barriers. So pathogens like bacteria and viruses are, for the most part, kept out of our deeper tissues by the skin. As chemical, your skin does protect us from some chemicals, but there are many chemicals that will penetrate right through your skin. That's why we need to be careful about handling certain chemicals, like if you're using paint thinner or something, wear gloves, or just don't get. That's the kind of thing that can penetrate right through your skin into your tissues. Gasoline can do that. Some people are really careless about that. And, I remember when I was a teenager, there's these 3 brothers I went to school with, and they were friends of mine, and their dad owned a gas station, and they all worked there, pumping gas. Back when you couldn't pump your own gas. And remember one time, which one was it? It was Bob, Dave, and I forget the other dude's name. But he was pumping gas, and I stopped and was talking to him. And they all smoked cigarettes, of course. And, he had this old Zippo lighter, the kind that you have to put lighter fluid in once in a while. And he was standing there, and he was lighting a cigarette right there at the gas pump, which is stupid to begin with. But then he couldn't get his lighter to work, so he pulled the lighter apart, took that gas nozzle and squirted gasoline. I mean, gasoline went all over his hand, and he just needed like 3 drops, but he squirted about a pint of gasoline on that thing, and he just shook it off and put it back together and wiped his hand and then lit it. He's lucky his whole hand didn't catch fire. Okay, inhibits evaporation of water. So your skin is pretty waterproof, so it holds water in. And one of the real risks or dangers of somebody who has bad burns covering much of their body is dehydration. There's nothing holding the water in their tissues anymore. Thermoregulation means regulating temperature or heat. So our skin helps us do that. When we get too hot, we sweat. the water in the sweat evaporates, and evaporation takes energy. Every molecule of water that goes from liquid to vapor by evaporating, it takes some heat energy with it. So that's why we feel cool when we're wet. Also, when we're hot, our body temperature starts to rise. Our blood vessels dilate. The blood vessels near the skin, they dilate, they get bigger to increase the blood flow near the surface of our bodies to allow more of the heat in the blood to escape into the surrounding environment to help cool us down. So that's called vasodilation. Just dilation means to get bigger. On the other hand, when we get cold, those blood vessels near the skin, they constrict to reduce the blood flow near the skin to conserve heat, so we're not losing so much heat from our blood to the surroundings. Okay, sensation. We have a lot of sensory receptors, different kinds of sensory receptors in our skin. So the word tactile means touch. So we have receptors for touch and pressure and vibration and heat and cold and pain, and those are all in our skin, and every one of them has a neuron that leads to the brain. So when something triggers one of those receptors, it sends a message to the brain that something is happening in that part of the skin, wherever it is. And making vitamin D. Vitamin D is synthesized or made in our skin, and it requires exposure to sunlight to do that. So that's why I recommended that we each get about at least 15 minutes per day of direct sunlight on our skin for that reason. Vitamin D is vitamin D becomes a hormone that helps us absorb calcium from the food we're digesting into the blood, and this is why if you buy a bottle of calcium tablets at Walmart or CVS, a lot of those calcium supplements will also have vitamin D in the same capsule, because it doesn't do much good to take calcium tablets if the calcium is not going to be absorbed into your blood. The vitamin D helps that happen.
So would you say when you take a vitamin D, you should take a vitamin C? When you take a vitamin D, you should take a vitamin C? Just like
well, vitamin C is not calcium.
Right.
But well, I'm just saying when you take calcium, it might be good to take vitamin D also, especially if you don't get enough, if you're not outside enough in sunlight to make your own vitamin D. Okay, this is just telling us how the skin contributes to homeostasis of other organ systems. Okay, so here's again a nice diagram of skin, the epidermis on top and the dermis below that, and see the where they connect is this wavy boundary between the epidermis and the dermis. And so here's the subcutaneous fat. It's thicker on some people than others. So we'll talk about each of those, the important structures in the epidermis and dermis. in a minute. Okay, the epidermis is mostly these keratinocytes. These are just skin cells, the kind that are always rubbing off and flaking off of us. And they're called keratinocytes. Cyte means cell. Keratin is the protein that they fill up with, the cells fill up with. So we'll see that these cells, well, I'll talk about that later. But other cells in the epidermis, melanocytes. These are in the bottom layer of the epidermis, and they produce melanin, which is a brown pigment, brown color that we have in our skin. Some people have more than others. So the melanocytes add melanin to the keratinocytes to make them darker. These intraepidermal macrophages, a big long name, these are just white blood cells that live in the epidermis. And they're macrophages. Remember this word phagocytosis? No, endocytosis. We learned about endocytosis. And that's just where a cell some cells can change shape and surround a particle and take it inside the cell. And some of our white blood cells can do this. And that's called endocytosis. If it's taking in a solid particle like a bacteria cell or something, it's called phagocytosis. If it's taking in a droplet of liquid, anybody remember what that's called? Yeah, pinocytosis. Sorry, pinocytosis. So they're both endocytosis, but this one is like a cell eating something. This is a cell drinking something. But anyway, macro means large. So macrophage, as in phagocytosis, a macrophage is just a large white blood cell that can eat stuff like bacteria. And intraepidermal just means within the epidermis. So these are just white blood cells that live in the epidermis. So if you do have bacteria trying to get through your skin into your deeper tissues, you have white blood cells living in your epidermis their job is to intercept the bacteria like that and gobble them up. And tactile epithelial cells, these are just touch receptors. Like that's what's shown here. And so this would be a neuron leading to the brain. So if this is in your epidermis, something touches your epidermis there, that'll trigger this to send a nerve impulse to your brain. So let's look at okay, so here's a picture of the epidermis, the layers. So many layers of cells. So this will be stratified, right? Stratified epithelium. And because they're thin, flat cells, they are, what's the word for thin, flat cells of epithelium? Squamous. So that this is stratified squamous epithelium of the epidermis. And so here's a little melanocyte that adds the color to these other keratinocytes. Here's one of those touch receptors. And this would be the dermis down below that. So what did we see? Oh yeah, so they're shown here are these 5 sets of layers in the epidermis, 5 sets of layers of skin. They're all stratum something. So stratum basale, spinosum, granulosum, lucidum, corneum. The one at the bottom, the base of the epidermis is called the stratum basale. Just Latin for base. So this is the layer of cells that are always dividing to make more cells because they're always flaking off at the top and rubbing off. So we have to make more down here, and then they just move up as they flake off at the top. So these cells that start out down here, in a few days they'll be up here, and then later they'll be up here, and eventually they'll be at the top. So the next set of layers is the stratum spinosum, and as they move up, they're filling up with more keratin. This granulosum layer is called that because it has these so-called lamellar granules. These are granules of some kind of waxy material that helps make the skin more waterproof. And then this layer, the lucidum, this layer, the stratum lucidum, is only in the skin of the palms of the hands and the bottoms of the feet, the soles of the feet. That's called thick skin. So we only have those two places, the hands and feet. And all the other skin of our body does not have this stratum lucidum. It just has the other four sets of layers. And then the very top, the stratum corneum, these cells are dead. So as they move up, they're filling up with keratin, they're getting thinner and flatter, and then up here, these are dead by the time they get to this stratum corneum layer. So this is just like a little flat sack of keratin. It's not alive anymore, and they're the ones that are always flaking off and rubbing off. Okay, what else? Yeah. Because here's a mnemonic, a way of remembering the layers. Come on, let's get sunburned. The first letter of each of those words corresponds to those. Okay, sorry. Yeah, so cells are dying as they move up. And that's lucidum is a layer that's only in the thick skin. And the corneum. And this word callus means says abnormal thickening of the stratum corneum, and that just happens in your skin gets thicker like that if there's some abnormal rubbing on skin in certain locations of your body. So if you wear shoes that don't fit right and they're rubbing somewhere, the skin will get thicker there. That'll be a callus. People who work with their hands, like carpenters, they're always handling wood and stuff, or bricklayers. They get thick calluses on the palms of their hands. Okay, another a different diagram, again showing melanocytes. These are the cells that are dividing to make more skin cells over time. Langerhans cell, that's one of those white blood cells that live in the epidermis. So this word keratinization just means adding more keratin to the epidermal cells. Okay, practice questions. Some disorders. Albinism is a genetic condition in which the person's skin does not make melanin, and usually the hair also, and even the irises, the colored part of the eyes, are very light. To have that condition, the person needs to inherit the gene for that from both parents. If you have just one copy of that gene, you'll be a carrier and you won't have albinism. But if you have two copies of it, then you would have albinism. This vitiligo, patches of areas on the skin that just don't have melanin. They're just much lighter than the rest of the skin. So it's believed to be an autoimmune disease, which means it's caused by the immune system attacking the melanocytes in those parts of the body. There was a famous guy who had that. He died. You know what I'm talking about?
Did you say he died?
He died.
No, I know. I don't think it was Scottish.
I mean, he was African American, so he normally had pretty dark skin, but as I understand it, he got the vitiligo.
You saw my Beck.
Yeah, Michael Jackson. So didn't he get the rest of his skin bleached to match the? That's the story anyway. I don't know. Dandruff, just excessive shedding of keratinocytes on the scalp. And psoriasis, keratinocytes divide abnormally fast, and it just produces the thick, they call plaques, the thick patches of skin. I've read that or heard that most of the house dust in our houses is just the skin cells that fall off of the people living, along with dust mites, little tiny arachnids that eat the skin cells on the floor and everywhere. Okay, so the dermis. This is below the epidermis, and has dense, irregular connective tissue, so it has a lot of collagen running through it for strength. And don't worry about these words, papillary and reticular. The word papilla means bumps. So the upper part is called the papillary, just because of the bumpy shape of the top of the dermis where it meets the epidermis. These would be called papillae, these bumps. And then the part below that is called reticular. But don't worry about those words. I don't care about that. Yeah, don't worry about the difference. But fingerprints, so-called epidermal ridges. They're, of course, as you know, different in everyone. Your fingerprints probably don't match mine. But their function, they do have a function. They make the surface of the skin less smooth so that it's easier to grip stuff. Fingertips are not as slippery. Okay, melanin in our skin. There's also melanin in hair of people with dark hair. So the hair follicles have their own melanocytes for adding color to the hair. So melanin can affect skin color, darkness of skin. Actually, it's better to have more melanin, because the more melanin you have, that melanin filters or blocks ultraviolet radiation from the sun, and that's what causes skin cancer. So darker skinned people have better protection against the ultraviolet radiation from the sun. Another thing that can affect skin color, hemoglobin, that's the red protein in red blood cells. That's what makes blood red. Hemoglobin has iron in it, makes it look red. And some people who have blood vessels very close to the surface of the skin, it can affect the color of their skin, make their skin look reddish or more red or pink. Especially, what's that condition? People whose their cheeks are rosacea, right? Their cheeks get very red because of that. And then carotene is a pigment in that it's not produced by your own body, by your own skin, but you can get it in certain foods that you eat. What kind of food do you think has carotene in it? Yeah, carrots. Right. And I don't know. I've heard and read that people who eat a lot of carrots, it'll affect the color of their skin, make their skin kind of orange. I don't know. Is that true? Anybody know? I couldn't tell. I'm so colorblind anyway.
According to Bugs Bunny, it's not that.
Oh, Bugs Bunny?
Yeah.
Oh, that would be an expert on carrots. So, okay, these sensory receptors for touch and pressure and vibration and stuff, there's different kinds with different names. Don't worry about them. You don't need to know those. And then other structures in the skin. So accessory structures. So these are things that are not skin, but they're part of the integumentary system. So hair, these sebaceous or oil glands, sudoriferous glands, which is sweat glands, and then ceruminous, which is earwax glands, and then the fingernails and toenails. So hair, don't need to say a lot about this. This condition, alopecia, there's different kinds of this alopecia. It just means hair loss. One type of alopecia is just like what I got, just male, called male pattern baldness.
What do you mean when your age is gone?
Huh? What? Is that a bald guy joke?
No, I said, what does it mean when women don't have their hair right here, like edges gone?
Oh, yeah, that's a kind of alopecia. Yeah, it's pretty common. Yeah, but of course it can be caused by chemotherapy, cancer treatments, a lot of reasons for it. Some people just, I think, is it alopecia areata? Is that the one where people lose all the hair on their head and their whole body? They lose their eyebrows, eyelashes, all of it. I think it's alopecia areata. Is that right? I don't know. That one's, I think, an autoimmune. I think, again, the immune system attacks the hair follicles. Okay, parts of the hair we don't need to. But again, there's melanocytes at the hair follicle to add pigments, more so to people with dark hair, of course. But the hair grows here and then it just pushes its way out. Well, every hair has a little tiny muscle called erector pili muscle attached to it, And that little muscle, it doesn't have much function in humans because it just makes your hair stand up on end. And when that, so when that happens, sometimes when you're cold, your hair will stand up, or in certain stressful situations, it'll cause hair to stand up. And I think in sexual arousal that can happen. But so it'll cause this muscle to contract, and the hair will stand up, but it also makes a little bump. That's what a goose bump is. It's just that little erector pili muscle contracting. And that, that's not important in humans. But in other animals, it's pretty important. Birds have the same thing on their feathers, and you may have noticed that birds in really cold weather, they look like their feathers are all fluffed out, and they look. A bird will look like a round ball almost, and that's because their erector pili muscles are making the feathers stand up, and that makes a thicker layer of insulation. When it's not so cold, their feathers just lay down flat. Same thing with in animals with fur. In cold weather, their hair stands up to make a thicker layer of insulation. And also, when some animals are stressed, their hair stands up like dogs do that. Some dogs, when they're really angry, you can see the hair stand up on their backs. And that means, if your neighbor's pit bull is doing that, that's not a good time to pet him. Okay, what else? The sebaceous glands, the oil glands are attached to the hair follicle, and the oil comes out along the shaft to help waterproof the skin and hair. Yeah. Remember that I was talking with Janet Sims. Any of you guys know Janet Sims? She retired a year ago or so. She used to be the dean of allied health here. She was in charge of all the nursing. And I was talking to her one time, and she was talking about that TEAS test that you guys used to have to take to get in the nursing program. And she was saying, some of the questions on that TEAS test are just stupid. She said there's a question on there about erector pili muscles. Who cares if nurses know about goosebumps? Nobody goes to the hospital for goosebumps. I agree. There's certain things that you shouldn't waste your brain learning about stuff that you're never going to be used. There's plenty of important stuff to learn.
Did her husband used to teach out here too?
What's that?
Her husband, singing. That was that different instructor.
Her husband?
Yeah.
I don't think he was an instructor here. No. Okay. These sebaceous or oil glands. This oily stuff that they produce is called sebum. Acne is believed to be caused by these sebaceous glands getting just this accumulation of this sebum that like clogs the hair follicles or the pores and causes a little tiny infection there. Okay, the sweat glands, sudoriferous. Got to have a special word for everything. So sudoriferous glands. So there's two kinds of sudoriferous glands, the eccrine and apocrine. Eccrine is the kind of sweat glands that produce the very watery sweat that we produce when we're hot, and it's for cooling, mostly for cooling. It's also some some excretion. So excretion just means getting rid of waste products. So there's a lot of stuff in salt and sweat, like salt and urea. Some of the same stuff that's in urea in the urine. Um, and sweat, this eccrine sweat has its own antibacterial chemicals or enzymes in it to prevent bacteria growing on our skin too much. But the antibacterial is not 100% effective, because people who sweat a lot and don't bathe very often, they'll start to smell bad, and that body odor is from the bacteria growing on their skin. Apocrine sweat glands. This is these are only in certain parts of the body. It tells us armpits, nipples, genitals, eyelids, and ears. And this sweat is not for cooling. It's stimulated during emotional stress and sexual excitement, and it has its own smell. And this is not the bad body odor smell. This is this apocrine sweat has its own smell that a lot of people find attractive, and that's why you got pheromones with a question mark. So the question there is, do humans have pheromones? Pheromones. Yeah, in other animals, like it's airborne chemicals, odors that an animal releases to have some kind of effect on other animals, like when a female dog goes into heat. We call it heat, which means she's sexually receptive to males. She'll put out pheromones that will attract dogs from all over. They'll smell that and know that she's in heat. Insects like ants make several different kinds of pheromones. Each one has a different message to other ants in that colony. But so the question: do humans have pheromones?
Yeah, because I can put perfume, she can put on perfume, but it's gonna smell different.
It smells different, yeah. And have you noticed that some men just naturally smell better, that's more attractive to you than others do? So, so humans probably, I think humans do have pheromones. I think so. I think there's even been some colognes that supposedly try to mimic so-called human pheromones. So you put that on, and you'll be a chick magnet. I've never tried it. Okay. So this would be a sweat gland. The sweat gland itself is down here in the dermis, but it has a tube or duct leading to the surface where the sweat comes out on the skin. Okay, then the earwax glands, ceruminous glands. Cerumen is a word for earwax. It says modified sweat glands. So these are in the skin, in the ear canal, that leads to the eardrum back in there. A couple years ago, I never had trouble with earwax before. Was never an issue. But then I got earwax in both ears. More one ear than the other. I think the right one more. I just obviously had too much earwax because I couldn't hear very well. It sounded muffled. And I tried everything to clean that earwax out. I mean, obviously not literally everything, but over-the-counter ear drops and stuff I learned about on YouTube. Mixing, I don't know, vinegar and alcohol, or alcohol and hydrogen peroxide, or even warm olive oil. Put that in there and lie on your side and leave it in there for 20 minutes and flush that out with warm water. Just nothing worked. And I ended up going to a doctor, paid $80 to have it cleaned out. It took him 5 minutes with this special tool. Okay, nails. So the nail bed is here below the nail where it's attached to the skin. The root here is where it grows. So as you know, I'm sure it grows here and it just pushes out. Which grows faster, fingernails or toenails? Hmm?
Depends on the person.
They grew up the same.
Is there an answer?
Toenails.
Think toenails faster?
Yeah, because you don't mess with them, like your feet are covered versus your fingers are deep.
No, fingernails go like I've read 2 to 5 times faster than toenails. So on a toenail, if you put a Sharpie, a mark with a Sharpie here, it would take a year for it to get to the end.
Oh my God.
Yeah.
I want my toenail grow faster than that. I mean, you know, say go by toenail polish when you get your toes.
Oh,
done.
yeah.
Yeah.
That's what I read. Okay, I don't know. Don't need to know much more about nails. Protect the ends of the fingers. Makes it easy to pick up some things, I guess. Grooming and scratching, that's important. Okay, we don't need to know all this stuff. The cuticle, of course, is this part here. Okay, hypodermis. So subcutaneous or hypodermis, mostly adipose tissue, thermal insulation. So I get cold easier than a lot of people, probably because I don't have very much adipose tissue. And,
Me too, I'm still cold.
I
I'll make my adipose tissue working right.
I'm okay if I'm moving around, generating body heat, but if I'm just sitting and not moving, I get cold. That's why I'm always wearing extra clothes, even when other people are in a t-shirt. I'll have a t-shirt and a long sleeve shirt on over that, and I might still get cold. Okay. Healing of wounds through the skin. Epidermal, if it's just a shallow cut through all the way through the epidermis and just partly through the dermis, then that healing would be called epidermal wound healing. That happens pretty easily and pretty quickly, usually with no scar. But deep wound healing, that would be through the dermis and even into the subcutaneous. Let's see if this video works. This link.
roughly square feet in adults. Though different areas of the skin have different characteristics, much of this surface performs similar functions, such as sweating, feeling heat and cold, and growing hair. But after a deep cut or wound, the newly healed skin will look different from the surrounding area, and may not fully regain all its abilities for a while, or at all. To understand why this happens, we need to look at the structure of the human skin. The top layer, called the epidermis, consists mostly of hardened cells, called keratinocytes, and provides protection. Since its outer layer is constantly being shed and renewed, it's pretty easy to repair. But sometimes a wound penetrates into the dermis, which contains blood vessels and the various glands and nerve endings that enable the skin's many functions. And when that happens, it triggers the 4 overlapping stages of the regenerative process. The first stage, hemostasis, is the skin's response to 2 immediate threats: that you're now losing blood, and that the physical barrier of the epidermis has been compromised. As the blood vessels tighten to minimize the bleeding in a process known as vasoconstriction, both threats are averted by forming a blood clot. A special protein known as fibrin forms crosslinks on the top of the skin, preventing blood from flowing out and bacteria or pathogens from getting in. After about 3 hours of this, the skin begins to turn red, signaling the next stage, inflammation. With the bleeding under control and the barrier secured, the body sends special cells to fight any pathogens that may have gotten through. Among the most important of these are white blood cells, known as macrophages, which devour bacteria and damaged tissue through a process known as phagocytosis, in addition to producing growth factors to spur healing. And because these tiny soldiers need to travel through the blood to get to the wound site, the previously constricted blood vessels now expand in a process called vasodilation. About 2 to 3 days after the wound, the proliferative stage occurs, when fibroblast cells begin to enter the wound. In the process of collagen deposition, they produce a fibrous protein called collagen in the wound site, forming connective skin tissue to replace the fibrin from before. As epidermal cells divide to reform the outer layer of skin, the dermis contracts to close the wound. Finally, in the 4th stage of remodeling, the wound matures as the newly deposited collagen is rearranged and converted into specific types. Through this process, which can take over a year, the tensile strength of the new skin is improved, and blood vessels and other connections are strengthened. With time, the new tissue can reach from 50 to 80% of some of its original healthy function, depending on the severity of the initial wound and on the function itself. But because the skin does not fully recover, scarring continues to be a major clinical issue for doctors around the world. And even though researchers have made significant strides in understanding the healing process, many fundamental mysteries remain unresolved. For instance, do fibroblast cells arrive from the blood vessels or from skin tissue adjacent to the wound? And why do some other mammals, such as deer, heal their wounds much more efficiently and completely than humans? By finding the answers to these questions and others, we may one day be able to heal ourselves so well that scars will be just a memory.
It's pretty good. Okay, so like he was talking about the fibroblasts. Remember, fibroblasts are the cells in connective tissue that produce the fibers, the collagen fibers. So those fibroblast cells move to the site of a wound, and they'll fill in the wound with collagen fibers, and then the epidermis above it'll heal from the edges in, rebuilding the epidermal layers. But as that happens, there can still be this fills in with collagen here. This is cut deep into the dermis, fills in with collagen. Even after the epidermis heals over that, you can still see it just doesn't look like the surrounding skin, because of that collagen underneath there, and that's what makes it appear as a scar. So he talked about these 4 steps: inflammatory. So this is the immune system response. The white blood cells come. Increased blood flow to the site. That's what causes swelling and redness, and it can feel hot. Then the migratory phase. The fibroblasts migrate or move to the location and add collagen fibers. And proliferate. To proliferate means to grow. So the epithelial cells grow over to fill in the wound, and then maturation when it finishes healing. The scab comes off. Epidermis is back to normal, but there could still be a scar if there's a lot of collagen under the epidermis. Okay, pictures. Okay, aging. So I haven't found anything good that happens to your skin as you get older. Wrinkles, decrease in fibroblasts, so you get less collagen and elastic protein fibers in your skin. So your skin gets weaker and less elastic, not as stretchy. Like you do something like this. If I pull up my skin on the back of my hand, if you do that, it'll probably snap back immediately. On mine, I still see like a little tent there, even after a few seconds, because my skin's just not as elastic. I get injured easy. Sometimes I'll just bump my hand on a table, and then I'm bleeding just from, it'll just tear the skin open. I get little bruises from bumping my hand, or work on my truck, and I squeeze my hand in someplace to get to a nut or bolt, and then I'll have these purple bruises on my hand just from doing that. That never used to happen. Dehydration and cracking. The sebaceous glands don't function as much. They don't produce as much oil, so your skin gets more dry. Less sweat. Decrease in melanocytes. In the skin, that's what causes gray hair. The hair loses its pigment, and also in the skin. I used to get suntan really easy. I'd be outside for a couple hours on a sunny day, and my skin would be noticeably darker. Now that never happens. I never get a suntan anymore. I can be out in the sun all day. I don't do that. I wear hats a lot. A subcutaneous fat is lost. A general decrease in skin thickness. That's why one reason that people, especially thin people like me, their faces change. My face looks thinner than it used to, because I just used to have more subcutaneous fat beneath the skin on my face. And, like I said, atrophy of sebaceous glands, that means they stop functioning. Nails become more brittle. So, okay, bed sores, pressure ulcers. Anybody who works with patients who are bedridden for a long period of time, you need to be aware of this for sure. Any place where the body is in contact with a surface, even a soft surface like a mattress, the pressure can result in sores like this. So that's why it's important to change the position of the patient regularly, pretty often. And if a wound like that, you think that's easy to heal? That's like a 3rd-degree burn because the skin is completely gone down to the muscle. That can't heal from the bottom up. The skin would have to heal from the edges in, which would take forever if it would happen. Especially in patients who are diabetic, right? Healing is especially bad. And my older brother had a wound on his heel. I don't think it was from a bed sore, but so something he hurt himself. He was diabetic for years, and he had that wound on his heel for years. And he even went to a wound clinic to try. They were trying to get it to heal, and never did heal. And then one morning, he didn't even realize it had gotten infected. Obviously, very badly infected. He sat up in bed and put, the way he described it, I put my foot on the floor and it exploded. His heel just exploded, and all this infected tissue came out, and pus, and they had to amputate his foot for that. And a few years later, he lost the other foot, and he died a year.
Was he a diabetic?
Oh yeah, for years. Yeah, he had many health problems. He just died a year and a half ago. Okay, skin cancer. So what is cancer? What's going on? There's many different kinds of cancer. Did we talk about cancer in here at all? So what? Many different kinds of cancer. There's over 100 kinds because it can affect different tissues and organs and organ systems. But they all have something in common. Cancer is cells of the body dividing out of control. Normally, your cells of your body divide when they're supposed to divide, and they don't divide when they're not supposed to. So some cells, like skin cells, they're dividing all the time because you need to replace the ones that are rubbing off and falling off. Red blood cells, we've got billions and billions of them, and each one only lives for about 4 months, and then they die. They just wear out and die. So we always have to be making more of them by cell division. Cells divide to make more. That's how cells reproduce. Other cells, like cells of your muscles, your skeletal muscles, they don't divide. Like the muscle cells that you have when you're born, that's all you get. They don't ever divide. So that's all controlled by genes. Genes tell your cells when they should divide and when they should not divide. But if there's a change in a gene, some kind of mistake in that changes the DNA in genes. Remember, DNA is 2 strands of nucleotides that we can think of as letters, right? A, T, C, and G. So I'm just making this up. This is the information stored in that cell for telling that cell everything that it needs to know to be a cell, and including when it should divide and when it should not divide. And so what if something would happen and this would accidentally become an egg or something? Or what if this was a gene and it would accidentally break here and here, and then this section would come out and it would flip upside down and reattach in there. Now those letters are in the reverse order. So that's called a mutation. That's what a genetic mutation is. Just an accidental change in the nucleotides in a gene, so that now the message isn't what it's supposed to be. The information is wrong. So now, if that happens to one of the genes that controls cell division, now the cell might think it's supposed to divide now, so it'll divide, and then the two daughter cells, they'll think they're supposed to divide because they got the same mutation. They'll divide, and then they'll divide, and then they'll divide, and they're just dividing out of control. They don't know when to stop. And those cells that are dividing like that, if that's happening in your lung, your left lung or something, those cells will never become normal lung cells. That's called differentiation, when a cell becomes a particular type of cell, like a lung cell or a skin cell or a muscle cell. They're just cells that all they do is divide and make more cells that divide, and they form tumors, and they just disrupt the normal functioning of the other cells in that organ or tissue. That's what cancer is, cells just dividing out of control. Every time a cell divides, there's an opportunity to make a mistake. And because when a cell divides, it'll copy every one of its chromosomes. Your cells normally have 23 pairs of chromosomes, but if a cell is getting ready to divide, first thing it'll do is copy every one of those chromosomes, so that now there will be enough chromosomes for the two daughter cells when it divides. But what if it's copying this chromosome and it accidentally puts a T instead of that G there? That's a genetic mutation, and that if that's in a gene that affects cell division, now that cell could be a cancer cell. It's going to start dividing out of control. And so, because every time a cell divides, it's an opportunity for a mutation to happen. Cells that divide a lot, divide very frequently, they're more likely to get cancer, because there's just more opportunities for a mistake. And what kind of cells divide a lot? Skin cells. They're always dividing. And they're all on the surface of your skin where the ultraviolet is hitting them every time you're out in the sunlight. So that ultraviolet radiation, that's energy that can go into your cells and hit the DNA and break the molecules and cause mutations. So that's why skin cancers are some of the more common kinds of cancer. So three types shown here: basal cell carcinoma. So it's called that because it's in the stratum basale cells at the bottom. And those are the cells that are dividing all the time to make new skin cells. So they're the most common, 78% of skin cancers, but they are the least dangerous. It says they rarely metastasize. What does that mean? Metastasize. Yeah, spread. Metastasize means to spread to other tissues or organs. So they can be treated by surgery or freezing that tissue. Relatively easy to treat. Can be just, the tissue can just be cut out. Squamous cell, these are not as common, but they're more dangerous. They often spread. So that's in the stratum spinosum cells, the layer right above the stratum basale. And then the worst is a malignant melanoma. Only 2% of skin cancers, but they're the most dangerous. They can spread really quickly and be fatal. And you can get a melanoma, and if it's on your back, it could spread to your spine, or spread to your lungs or liver, or the chest wall. So the melanomas are the ones that often are at the site of a mole. The word nevus just means mole. So a mole that starts out looking like this, if it changes, now it's looking like this, that needs to be checked out for melanoma. So if it changes form, it gets enlarged, and the edges are very distinct here. Now the edges are fuzzy, like it blends in with the surrounding skin. That could mean that it's becoming it's cancerous. So watch for that in yourself and people to you. Okay, burns. Burns can be electrical or from fire or heat or electricity or chemicals. And they are graded first, second, third, even fourth degree. But that depends on the depth, how deep the burn is. So first degree is just like a bad sunburn. No blistering. It'll be painful and red, but it'll heal in a few days. Or just if you scald yourself with hot water, that could be a first degree burn. If it's not bad enough to cause blistering like this, it could be second degree. So the epidermis has separated from the dermis, and there usually will accumulate fluid in between there. That's a blister. So pain, redness, edema or swelling. It'll heal by itself within a few weeks, but third degree is all the way through the dermis, and so even the pain receptors will be burned away, so it won't be painful in that center part of the burn, but around the edges it'll still be very painful, where there's still pain receptors. And because the skin is completely gone, it can't heal from the bottom up. It have to heal from the edges in. That could take a long time. Susceptible to infection, slow healing. So these are the kinds that are often treated with skin grafts. I had a third degree burn on my arm once. Some guy, I was out in my driveway, and some stranger pulled in because his car was overheating, and he didn't know what to do, and so I'm pretty good at fixing cars, so I helped him, and I was working on it, and I put my arm right up against the exhaust manifold where the exhaust pipes are connected, and before I knew it, I had a third degree burn there. It was about a ½ inch by an inch. It took forever to heal, and there's still a scar there. That was probably 20 years ago. Okay, fourth degree is into the tissues below the subcutaneous, into the muscle and even into the bone. Sometimes I use the word descriptions like partial thickness and full thickness instead of first, second, and third degree. And this rule of nines, this is a way of quickly and easily estimating how much of what percentage of the body, the surface of the body, is burned. And they use the fact that on an average person, each arm, the surface of each arm is about 9% of the total surface of the body. Each leg is about 18%. The trunk is about 36%. So these are 9, 18, 36. These are multiples of 9. And so they call it the rule of nines. And so this is used by paramedics and EMTs if they are transporting a burn patient. They'll radio ahead to the hospital and say this patient is burned over a certain percentage of their body. This is what they often use for that. It's not very accurate because even if just like 3/4 of the leg is burned, they'll call that 18%. And if only half of an arm is burned, they'll still call that 9%. But it's better than nothing. It's just a very quick estimate of the area that's burned. Okay, the callus, talked about that. It's just where the thing gets thicker in response to rubbing or abrasion. Talking about bed sores, keloids. It's a kind of a weird scar tissue that has layers raised above the skin surface. Some people get them on their ears, just like a big bumpy scar. That's where there's an accumulation of, I think, just a lot of collagen. I think even some people get that from bad piercings. Anybody know anything about that? Keloids? Where? What, was there a wound there originally?
She had a little scratch there. I'm sure we wanted to come up, and now it's probably about this wide.
Wow. Okay, stretch marks. I don't know much about that.
I do.
That can be from pregnancy too, right?
Mm-hmm.
Some people who are very overweight and they lose a lot of weight, they can have just way more than stretch marks. They just have a lot of extra skin. It doesn't shrink back necessarily in some people. I don't know why. Some people they lose weight and they get slim and they look fine, but other people, they just have all this extra skin that it just doesn't shrink back, and some people even have it surgically removed. Okay, practice questions. It's break time. Let's take a break.
Yeah,
You guys didn't pick up your exam, they're sitting here. Alphabetical, the grades are on the back.
Is that a new now? He's like, oh yeah. on your ass.
I have taken exams. I took 60 from the city. I'm not a state exam, but I have taken 60. I have taken the exam. I do all the the hospital. What's the best in I know that I've been working on it.
No, I'm sorry.
Are you doing like one? They you can see if they do that. Still on there. And you can. Yeah, but you don't get benefits. Because you can do like both. I don't know.
No. Actually, still.
Mm-hmm.
Now what are we gonna do? See who's here? You wanna do that? Play with that? I'd love it if you guys would occupy yourself with that.
Yeah.
I'll take a nap or something.
Okay.
Um,
First.
Well, somebody's not back yet. From break. Who was that? Anybody know who was there?
Our sub student, so she wanted to take it to.
Yeah, Mary's not here, right? LaTracy? LaTracy? Um, Kelly? Melissa's not here. Hannah? Kahala? Kahala? Not here. I don't know if that's who that was. Tiana? No? Shania? Sherry? She was here, wasn't she? Did she leave? Shaquala? Shaquala? Kaylin? Keisha? So, Graceland, right? Okay, so Graceland's here. Okay. Okay, I don't know, should we look at that worksheet for a few minutes? See if, I got copies of it here, if anybody did not bring yours with you.
Excuse me.
Oh, well. Okay, I don't know if we need to go through all of these. Some of these are too easy to bother with. Which type of tissue would be brain inflammatory? That's easy, right? Nervous. What is it? No, number one.
I was wondering that too, but I was going.
Okay, number two, epidermis, lining of internal organs. That would be what? Epithelial, right? Number four, ligaments, tendons, fat, and bone, connected. Right? Majority of the heart. What's that? Which type of muscle? Cardiac muscle, yeah. How does the type of tissue in an organ relate to its function? I don't know. Anybody want to explain? Uh, um, Look at number 6, yeah.
That is what the type of tissue in an organ that relates to function, because the tissues are specialized in doing specific roles.
Yeah, that's good. Each tissue is specialized for a specific role. Yeah, so, number 1, where are epithelial tissues in the body? They're covering surfaces and lining hollow spaces. Right? The function of epithelial tissues. Mostly covering, but also some epithelial tissues are glands, that glandular type of epithelial tissue. So it produces something, hormones or saliva or earwax. Epithelial tissue is passed on 2 criteria. What are they? What is it about the cells? Layer, either one layer or more than one, so simple or stratified. And what else? The shape of the cells, right? Squamous, cuboidal, columnar. So the layers of cells and the shape of the cells. What does avascular mean? Yeah, the prefix A means without or not. So and vascular means blood vessels. So it just means epithelial tissue typically does not have blood vessels in the epithelium. Why is it important that cells of the lungs and digestive tract be simple instead of stratified? So what happens in the lungs and the digestive tract? Thin tissue would be good for something to pass through it easily, right? So in the lungs, oxygen is passing through from the air we inhale into the blood, and and carbon dioxide moves some of the blood into the air to be exhaled. So it's important that layer of tissue that the oxygen and carbon dioxide have to pass through be thin, right? So simple squamous would be good for that. And also, in the digestive tract, that's where we are digesting food into small enough molecules that they can be absorbed into the blood. So again, that tissue should be thin for the nutrients to pass through it to get into the blood. Why is it important for skin to be stratified epithelial instead of simple? So what if skin was only one layer? Would that be good? We always have layers of skin flaking off and rubbing off, so that's why we have to have several layers, or else we'd run out of layers if there was only one. Transitional. What's so special about transitional epithelium that's different from others? It can stretch. Transition means change, so it stretches and then shrinks back. How is this beneficial? It's beneficial in organs that stretch. They fill up with something and stretch, like the urinary bladder, right? It fills up with urine and then it shrinks back when you pee. And that transitional epithelium stretches without leaking. Number 10. What are goblet cells? What do they do, Crystal? Yeah, mucus. I see Crystal because we went over that. So goblet cells produce mucus. So wherever you have mucous membranes, there's goblet cells in those mucous membranes, like in your respiratory system and your whole digestive system are lined with mucous membranes. Do epithelial cells reduce rapidly or slowly? Yeah, rapidly, like skin. Because epithelial tissues are typically covering or lining some space that would often have something flowing through it or passing through it that would tend to rub off the cells. Epithelial cells tightly packed or loosely spaced? Tightly packed. So they're in layers, side by side, joined together very, very closely. Okay, looking at epithelial tissue under a microscope, several layers with flattened cells on the apical. Apical means the top surface. What type of epithelium would that be? What is Hannah? Stratified squamous. Yeah. So stratified means several layers. Squamous means thin and flat. It should be pretty easy. Which type forms membranes where filtration or exchange of substances by diffusion occurs? Simple or stratified? Simple, thin. Thin would be better for that, right? We talked about that earlier. So, wherever there's something passing through, or something passes through, like oxygen or nutrients, a thin epithelium would be best for that. So simple. Epithelium subject to considerable wear and tear, like the skin, should it be simple or stratified? Stratified, of course. Okay, type number 11 through 14. Type of epithelial tissue in the following structures. So epidermis, esophagus, oral cavity. But we know that epidermis we should all know that epidermis is stratified squamous, right? Stratified squamous. Respiratory, what is that? That's columnar. It's columnar, right? Or columnar or pseudo-stratified?
They can't be, they don't have to be, do they?
It
Or
could
do
be,
they?
the trachea, I'm talking about the trachea.
Yeah.
That's ciliated, right?
Yes.
Ciliated.
Pseudo.
Is it ciliated pseudo?
Pseudo-stratified.
Ciliated pseudo-stratified. I won't ask that on the exam. But, I mean, some of these you should know that,
Yeah.
that the air sacs in the lungs, that should be simple squamous. Skin is stratified squamous. Air sacs in the lungs, so that would be simple squamous. Digestive tract, I don't know, is that columnar? Simple columnar? I don't know. I won't ask that on the exam. If I don't know the answer, I need to find out. What about glandular? Glandular epithelium, what shape are those cells? Remember that in a gland, inside of a gland, there's there would be a tube, and then inside the gland there would be some kind of tubes, maybe branching tubes like this or something. And yeah, these these cells that surround these tubes they're cuboidal. Like if this was a salivary gland or an earwax gland or something, it's these cuboidal cells surrounding that tube that would produce the stuff, the saliva or earwax that would then come out through there to the surface of the skin if it's a sweat gland, or to the inside of the mouth if it's a salivary gland. But so this glandular epithelium is usually cuboidal, box shaped. I don't know what else. There's 15 minutes to go. We don't have to stay that long. Okay, should know this difference between the differences among the three kinds of muscle tissue. So which of the three types is voluntarily controlled? Only one of them is skeletal. In fact, that's the only tissue in your body that's voluntarily controlled. So involuntary, that would be the other two, cardiac and smooth, right? They contract or relax automatically. We can't think about it and make it happen. Which one or ones would be stratified? Yeah, both skeletal and cardiac. Smooth is called smooth because it's not striated. It doesn't have those visible lines across it under a microscope, so it looks smooth. One nucleus in each cell. One of these types of muscle tissue has multiple nuclei in each cell. Which ones are long like spaghetti? Which of the three types of muscle tissue has the cells are long like spaghetti? Skeletal. Like this muscle, the biceps muscle, each of the cells that make up that muscle runs the whole length of that muscle. It's long like spaghetti. And those long spaghetti cells, each one has several nuclei along it. Remember, those skeletal muscle cells. Each one started out as a bunch of short cells connected end to end, and each one had a nucleus. But then they all fused together into one long cell, like spaghetti. But they still have all those nuclei from when they were several cells. The cardiac and smooth muscle each have only one nucleus per cell. What's the term we use for cells in muscle when we're talking about muscles? Fiber. A muscle. The word fiber. If we're talking about muscles, a fiber is a cell. Okay, so single nucleus would be cardiac and smooth. Several nuclei would be skeletal. Attached to bones.
I thought I wrote it wrong.
Attached to bones would be obviously skeletal, right? So the skeletal muscle is the kind that moves your joints, bends and straightens and twists your joints. Allows you to direct your eyeballs. So if I look left or right, what kind of muscle am I using? I can control that voluntarily, right? So it must be skeletal. Right? If you can control it voluntarily, then it's skeletal. In the walls of your stomach, uterus, and arteries, smooth. has spindle-shaped cells. That spindle, that's word spindle-shaped. That I guess that means it's kind of long and pointed at the end. Which type is that? Would that be? Skeletal is like spaghetti. No, cardiac's muscle fibers are branched. Remember, they're branched. But so it's the smooth kind. Smooth. Okay, the branching cylindrical cells, that would be cardiac. And intercalated discs, I'm not sure we talked about that, but intercalated discs are in cardiac muscle where one muscle cell connects to the other end to end. And this thing has tissues. So here's cardiac muscle. See these lines across here? Those are the intercalated discs, where one muscle fiber meets another one end to end, and connects them together. Only cardiac has that. That's different. That's not the striations. The striations are very faint. In fact, I don't think I can even see striations on there. Even this close, I can't see striations, even though cardiac muscle is striated. Long non-branching cylindrical cells, like spaghetti, that would be the skeletal. Concerned with locomotion of the body as a whole. Skeletal, right? Changes the internal volume of an organ as it contracts. Smooth, but it could also be cardiac, right? Because that's what the heart does. So it could be either one, smooth or cardiac. Both do that. And tissue of the heart, cardiac. Okay, let's identify the major tissue types described below. So lines body cavities, covers body's external surface. So that's epithelium. Pumps blood, that would be muscle, right? Cardiac muscle, so it's muscle. Transmits electrochemical impulses. Nervous. Anchors, packages, and supports body organs. Connected. Number 5, cells may absorb, secrete, and protect. That's epithelial. Epithelial, yeah. Secreting would be the glands. Absorb. I guess like the epithelium that lines your intestines, they absorb nutrients through it. Number 6, most involved in regulating and controlling body functions. Nervous. Number 7, major function is to contract. Muscle. Contract means gets shorter. Synthesizes hormones. No, that would be like this glandular epithelium, right?
Epithelium.
So it would be epithelium. The most durable type, tissue type. Now, I don't know. What would be the most durable? What do I mean by durable? I mean, my bones last me a lifetime. They're pretty durable, but skin is durable because it's always replacing itself as it rubs off. but I don't know. I don't know the answer. I don't have an answer key. Abundant non-living extracellular matrix. So what kind is mostly non-living material? Epithelium is mostly cells. Oh, yeah, you're right. In the case of skin, the top layer is dead, non-living, but think of something like bone or cartilage.
Connective tissue.
Yeah, connected. That's some, well, I'd say some connective tissues are mostly non-living, but not all of them. Like adipose tissue is almost all cells, and that's alive. But some, like bone tissue and cartilage, and tendons and ligaments, that's all collagen, almost all collagen fibers, so that's mostly non-living. But I think connective is the best answer. Most widespread in the body. Yeah, I don't know. We got muscles everywhere. We got epithelial everywhere. We got connective everywhere. I don't know what. All of them. Number 12 forms nerves and the brain. What is this? I had something up here. There we go.
Connective tissue.
What do you think that is?
Nervous tissue to nerve.
Remember I said to me neurons kind of look like a kite. Does that kind of look like a kite? That's what I meant. Use your imagination. It kind of looks like a kite. Okay, what else?
So the axon, the on the right piece is kind of down.
Yeah. Yeah, I think these are dendrites, and this is. I guess that's the axon. It's hard to tell, but you can't see the how long this is. Not sure. Some dendrites. This is all nervous. It's not very good. I had to find some good nervous tissue slides. Okay, type of connective tissue based on the following description. Cells surrounded by a fluid matrix that transports substances. What would that be? Blood. So blood is considered a connective tissue. What's the extracellular matrix in blood? The plasma. It's a liquid part, non-living. That's what extracellular matrix means. Number 8, cells surrounded by a hard matrix that supports and protects. Hmm? Number 8, what is a hard matrix, hard extracellular matrix that supports and protects? Bone, yeah, I think bone. Number 9, contains cells that reduce friction and allow flexibility at joints. Hmm? Oh, that's not a tissue.
Oh, yeah, tissue.
Well, I don't know if
Connective
it's
tissue.
synovial fluid. I don't think that's considered a tissue, but I think cartilage.
Going down the line here.
So I think number 9 is cartilage, right? Number 10 contains cells that stores energy, insulates the body, and cushions organs. What would that be? Yeah, adipose, right? Fat is a way of storing energy. So if you're ever starving to death for a long time, it's good to have adipose tissue. Yeah, I would probably die first. Then you guys could no cannibalizing. What are 2 types of cells and how are they different? Oh, nervous tissue. 2 types of nervous tissue cells. What are they? What are the ones that conduct nerve impulses?
Neurons.
Neurons.
Oh, yeah, and neuroglia.
And yeah, and then the neuroglia. That's the way I say it, neuroglia. But those are helpers. All you need to know for now is that those are helpers for the neurons. There's a bunch of different kinds of neuroglia. Okay, for muscle. What are muscle cells called again? Fibers. What are the functions of muscular tissue? It contracts and produces a pulling force for movement. Right? Number 3, which muscle type is exhibited for each characteristic? We already did something like that. Yeah, we did that. What's the difference between regeneration and fibrosis? And tissue repair.
I think regeneration, it's gonna, the cells rebuild themselves or divide, and then,
It's a regeneration replacing cells to repair the injury. What would fibrosis be adding?
muscle. That's inflammation of the muscle.
Is it it'd be adding extracellular matrix, non-living stuff, which would be like collagen fibers. It's like the fibrosis producing fibers, collagen fibers. Okay, so define tissue. What is tissue?
The group of cells.
The tissues are just the materials that make up the body. Right? And each type of tissue consists of 2 kinds of components, 2 kinds of parts. What are they? living and non-living, right? So the cells, living part, and what's the matrix, the extracellular matrix is the non-living part. So the extracellular matrix is different in different tissues. Like in blood, it's liquid plasma. In cartilage, it's the rubbery stuff. In bone, it's the hard white mineral. In epithelial tissue, it's usually the basement membrane below the layers of cells. Okay, well, on the back page, what characteristics do all connective tissues share in common? That's hard to say because there's so many of them are so different. Like adipose is nothing like blood, and blood is nothing like tendons. What do they all have in common? I guess they all have a lot of extracellular matrix and relatively few cells. So they're mostly non-living. Whereas like epithelial tissue is mostly cells, right? Mostly layers of cells with not so much extracellular matrix. Okay, function of connective tissues. I don't know, what is it? Protect, hold body parts together, support, cushioning, there's so many different kinds. Blood transports stuff. Okay, number 3, 2 factors that affect the consistency of a connective tissue. I don't like that question. Let's skip it. What's the extracellular matrix of connective tissue made of?
Non-living.
What's that?
Non-living.
Yes, non-living, but there's two parts. Generally two parts of extracellular matrix. There's usually protein fibers like collagen running through it, but there's also, what's the rest of it called? Like, what's the rubbery part of cartilage called? It's called the ground substance. Remember that ground substance? In bone, the ground substance is the hard white mineral, but it has collagen fibers running through it. So typically the extracellular matrix, basement membrane would be mostly collagen fibers. Okay, why does it take tendons and ligaments longer to heal than many bone injuries?
They don't have a lot of cells in their cells. No blood supply.
Yeah, not very many living cells, and not a good blood supply in the tendons and ligaments. When I used to work in engineering, there was a college kid, working at this company. He worked with me. He was an intern, and he was on the track team at the University of Cincinnati, where he was going to college. And he did one of the things he did on the track team was called the discus throw. You know what that is? It's like a big heavy metal frisbee. So to throw this thing, they wind back and then they throw it as far as they can. And he was doing that once at a practice, and he swung back and he went to change direction, and the ligaments in the front of his elbow snapped and his elbow bent backwards. And I shouldn't laugh, but I didn't like the kid. He was arrogant. And he was always giving me a hard time. But he had surgery. They replaced the ligaments from a cadaver. took ligaments from a dead guy and put them in, and it took about a year to recover completely, and so he could start back on the track team. And it healed so well that he went on. He was All-American, which means one of the best in the country at what he did on the track team. But that's all that keeps our elbows from bending back. It's ligaments. Okay, what substance makes up the rigid matrix of bone? Rigid means stiff, so that would be the hard mineral, the white minerals, like calcium phosphate. That's called hydroxyapatite.
Which one?
Number 6.
His name is Satani.
Number 7. What are 3 types of cartilage? That's a good question.
What? The next one, hyaline?
Hyaline is one. Fibro.
Yeah.
And what is it? So it's rubbery. What's another word for rubbery or stretchy?
Something with the H.
No, so hyaline was one of them.
Okay.
So it's hyaline, fibro, and
You tell us, we know you know.
well, you should think of it. What's a rubber band? How would you describe a rubber band? It's
Elastic.
elastic.
Oh.
I was trying to think.
That's a hyaline, fibro, and elastic. 3 types of cartilage. Number 8. Which type of connective tissue? I don't know. Transports oxygen, carbon dioxide, nutrients, and waste. What would that be?
Blood.
In arteries and veins, that should be easy. Blood. B. Dense connective tissue that connects muscles to bones and bone to bone. So there's two different. Well, that would be the dense regular connective tissue, but muscle to bone is tendon, bone to bone is ligament. But they're both the same kind of dense regular connective tissue. It's mostly collagen. I just read recently that your tendons and ligaments are stronger than steel by weight. Like a steel cable, you compare a steel cable to a tendon that weighs the same. The tendon is stronger than the steel cable. Pretty amazing. Let's see. Connective tissue that aids in formation of red and white blood cells. The tissue is found in spleen and marrow. That's connective tissue. I don't know what they're talking about. I don't know. Anybody have ideas? 8C. I don't know. What would be a type of connective tissue? I don't know. Okay. Well, I mean, we have red marrow, but it says and the marrow, so the word marrow is in the question. So I don't know.
Lymphoid tissue.
Where'd you Google that question?
That's what
the
it
bone
said, yeah.
marrow, okay.
But I didn't think it was that because it said marrow in it
But
too.
yes. Okay. D, connective tissue with one of the hardest extracellular matrices that form protective structures used for muscle attachment. So, bone. What's the hardest material in a human body? Or even harder than bone? What? Teeth? The enamel on teeth, that's harder than bone. Wouldn't call that a tissue because it has no living cells in the enamel, so it's just non-living material. Okay, loose connective tissue that separates the cells of the body from the bloodstream, go between for nutrients and waste that to leave and enter the bloodstream on their way to and from body cells. I don't know. Anybody know? Separates the cells from the body. Well, it seems like they're describing blood vessels, the walls of the blood vessels. But, yeah, but what kind of connective tissue are blood vessels made out of? I don't know. You Googling?
I am. Because then when I want to know the right answer.
Yeah. Well, the next one, fat, is what? Adipose. And the one after that, semi-solid connective tissue for both protective and supportive structures in nose, ears, ribs, and vertebral discs. So that would be cartilage. Dense connective tissue with irregularly arranged fibers that provide strength with tension and exert in various directions, such as in the dermis. Well, I think that's just called dense irregular connective tissue. H. Right? Where are connective tissues found? Everywhere. What's the function of connective tissue? We already answered that. But what do connective tissues have besides cells? They have ECM, extracellular matrix. Okay, I crossed out the next one. You don't need to know that. 5. How are they classified? Well, there's liquid, there's dense, there's loose. I don't know. What purpose do fibers like collagen and elastin provide in the ECM of connective tissue? Strength and flexibility. Okay. Any questions about that stuff?
The answer to that one that we didn't know.
Yeah.
E is areolar tissue.
Okay. Okay, well, we can, what can we do? Supposed to have 15 minutes left. Why don't we go play with this thing? Well, I'd like everybody to learn a little bit about this thing. Everybody come around. Okay, so this looks like a house that brings up this menu. So if I want to just cancel what we're exit, what we're going to just have to. This goes back to this toolbar, and this one here, the table EDU, if I click on that, it brings up that same menu that we had before. So for a class like this, what we would probably want to look at is cadavers of dead body. And there's a few of them in there. They're named distribution funds, Carlos. So these are actual people that these images were made from. And there's back on that previous menu for the toolbar, there was cadaver information is one of the items, and you click on that, and it'll tell you about what you need. So let's see if we can go back to that. Cadaver information. So here's the same names. So one of these, I think Carl says he died of lethal injection. And also one of them, Vicky, I think, Vicky or Carla, she died of stomach cancer. And but Hans, tells us he was 71 when he died. He was male, he was this tall, weighed this much, and he died of lung cancer. And it's got some, well, this is what killed him. That's lung cancer. These are cancer tumors. And it's, some more pictures down here. It says enlarged lymph nodes. And that happens typically when a person has a bad infection or cancer, because the lymph nodes are part of the immune system. His immune system was working overtime of the cancer, and so the lymph nodes enlarged like that. They often get tender and you can feel them, you feel them in the patient. But it says chest wall metastasis, liver metastasis, pancreas metastasis. So his cancer had spread from his lungs to these other tissues. So he was in pretty rough shape. He's probably a smoker. But we can close here and then let's look at his cadaver. Open up that menu with the cadavers. So let's go to Hans. There's a lot of information in that virtual cadaver, so it takes a couple of minutes to load it all. It has its own built-in computer. Last Tuesday, we've been having campus tours lately from schools, and did I tell you about this group? I think last Tuesday from Richmond County Middle School. We had 3 groups come through, and I was demonstrating this, and the third group, I mean, the kids loved this. They were really into it. I let them play with it after I demonstrated it, and they thought it was really cool. But the third group, I was doing it with Natalie Thompson, the instructor. She was showing them skeletons of various something. I was showing, she had half a group, and I had half a group here. There was, I think, 6 of them. And one of these kids said, I was wearing a white lab coat. He said, if I come here and take a class, do I get to wear lab coats? And I said, well, we got a husband in the drawers back there. And he looked, they said, that's going on? And I said, I don't care. So they all went over there. One of those third drawers of them were pulling out lab coats, putting them on, taking selfies. And that excited them more than this. And they wanted to show their mom. They wanted to look like scientists. And it was really cool. And I heard one of them say on his way out, this was fun. So you never know, but that kid might remember that 5 years from now.
Yeah, that's true. Yeah.
Just because it made him feel cool. Like we're doing surgery on you or something.
Yeah.
Anyway, so here's Hans, 71 years old at this point. So anyway, what you can do, there's different ways you can manipulate, but just one finger you can rotate. Looks like he was lying on a slab for a while, doesn't he? So flat on his back. But 2 fingers, move them around, and just like on another touch screen, you can make them bigger, smaller. Whatever position you're in, if you want to put them back facing normally, just do that. Want to put them sideways, drop down. But some of the things you can do, we don't care what he looks like outside. We want to see inside. So, one thing you can do, touch on this eyeball, and now these are the organ systems. They're all checked, so his whole body is showing. But if you uncheck, then you can just pick what you want. Just skeleton. So there's just his bones and cartilage and ligaments. If you want to add muscles, you want to just only digestive system. So what do we got? His esophagus that he swallows through leads to the stomach. This is all small intestine, large intestine, rectum. Respiratory. This is his trachea. There's his larynx, which are vocal cords. So he died of lung cancer. So let's look inside his lungs. One way you can do that. This is a scalpel. So it's just that's where we want to take a transverse section. Right? So if I touch him, just touch him either side of that, it'll disappear. So now do that rotating with one finger. So his left lung doesn't look bad. Pretty normal red, pink color, but that doesn't look good. It said they had lung cancer in the right superior lung, so in the upper part of his right lung is where it was worse. Undo that. Well, before we undo that, what if I wanted to cut a little bit lower? This is the one. No, it's this one. Yeah, this. So it just move this scroll bar and it just cuts lower down or higher up. We can do his whole body that way. see. Yeah, this one, yeah, it's this. It'll just like peel off layers. Like there goes the skin, now we're down to muscles. The muscles are gone down the bone. The ribs are going to disappear. Let's see what is. We can also, this other scalpel function is dissecting. And I'm not, I haven't really figured this out very much yet. I think you can make a cut. Cut. And if you touch it, it'll remove tissues layer by layer. So there goes the skin, touch it again, and I think it tells you, what you're removing or what you're seeing. Every time you touch it, it goes a little deeper. The sternum, the breastbone, some muscles. So it just takes a little off each side, and if you keep doing it, it'll go all the way through until it says black. It'll come out the other side. So you can undo. Anyway, you guys want to play with it? Help yourself. Anatomy watch. Paying an extra several thousand for that.
That would have been the big for your having.
I know, yeah. I definitely need to have like in the.
That would be neat.
Yeah, that's what I was just about to say. Like when you're learning, yeah.
We would like hurry to do our test and like go to the other room like.
That would be neat.
Good night, dear. Good night. Y'all be careful. Was this gonna be the other lab over here? With the brain?
No, that was for one of the campus tours that came through.
Oh.
For the kiddies to look at.
Oh, y'all be doing it up for them, don't y'all?
I know.
Yeah.
What's this thing? Oh,
It's a pig, dissected pig.
it's a real pig?
Yeah.
Oh, I thought it was the brain. Oh, this is the brain. What kind of brain is this?
Sheep.
Oh, okay.
Sheep brains?
Yeah, we'll be looking at them on this.
Sheep brain?
Mhm.
Oh, cool. What is it?
Dissecting sheep brain.
That's a sheep brain? No. What is this? A
Human.
human.
Trauma. Oh, human. Human. I thought it was
It's
a
a human
trauma.
brain?
So,
It's so small. Like this half. No. Like portion?
Yeah, it's like
Like a
cut.
partially
Yeah.
or-
nice.
Yeah.
I was like, there's no way that's the whole thing. These are cool.
Yeah, my little 5-year-old came home from kindergarten yesterday. She was like, "Do you know what bacteria is?" I was like, "Girl, what you know about bacteria?" She was like, "They get in your body. They're like germs, and it just starts out with one, and then they just get more and more and more." I was so impressed. I was like, "Oh my God, 5 years old, I barely knew my colors." They're so smart these days.
I know. I couldn't do
Yeah.
night.